Welcome back to 8 Minute AI. We're your hosts. I'm Michael.
Becca?
And Garvin, whenever you're diving into something new, it just makes sense to start at the beginning. And you can't have artificial intelligence without machine learning. So let's start there.
Yep, I couldn't agree more. And if we're talking about machine learning, we have to lay the foundation. What events transpired leading up to machine learning? A great place to start is with Alan Turing.
Who better to help us crack into ML than Alan Turing?
Exactly. Alan Turing was a British mathematician and logician, probably best known for his contributions towards cracking the Enigma code, which was an encryption system used by Germany during World War II. I'm sure saving countless lives and shortening the war.
Yeah, and the machine he designed to crack the code, it wasn't anywhere close to what we even think of as a computer. It had gears and rotors and reflectors. Looked much more mechanical than electrical.
Think of it as a steampunk style computer.
Then a bit later in the 1950s, he posed the question, can machines think? For many, that marks the beginning of the concept of artificial intelligence. He proposed a test, a mental exercise, to determine whether a machine could exhibit human-like behavior. The thought experiment is actually pretty simple. If a human interacts with both a machine and another human and cannot tell the difference, then the machine is said to be able to think.
And that's a pretty wild thing to imagine back in the 1950s. There were no chatbots or anything like that. Computers weren't even interactive, they were more like giant calculators.
And then a few years later, the term artificial intelligence was coined at a conference held at Dartmouth College. And that event is now considered by many the birth of AI as a formal field of study. But the concept of AI at the time was nothing like we're seeing today. It was rule based, relying on explicit instructions written by humans. It was more like what we now consider traditional computer programming. Definitely not what we're calling AI.
Yeah, early AI systems didn't actually learn from data. They just followed complex sets of predefined rules like a flowchart. These systems, known as expert systems, were designed to mimic human decision making by encoding knowledge in the form of if then statements. The only intelligence was exactly what was programmed into the system.
One of the most famous expert systems was IBM's Deep Blue, the chess playing computer that defeated world champion Garry Kasparov in 1997. Deep Blue's victory was a huge milestone for AI, but it wasn't actually using machine learning. Instead, it relied on brute force computation, analyzing millions of possible chess moves per second based on a vast database of recorded games and pre programmed strategies. While it demonstrated that computers could outperform humans in highly specialized tasks, it lacked flexibility and didn't improve from experience. It was just exceptionally good at following its programmed instructions. Fun chess fact, just after two moves each, there are 400 possible positions. After three moves, over 121,000. And after four moves, nearly 319 million.
That's a lot of chess and a lot of nerd right there. So, can someone beat Deep Blue?
Yeah, it's possible. Kasparov did actually beat Deep Blue, but only in single games, not enough to win an entire match. The strength of Deep Blue at the time made it extremely difficult to win consistently. With the power behind today's computers, I imagine beating a modern chess engine is virtually impossible.
Ah, okay. So, Deep Blue wasn't perfect, and it also needed more advanced hardware than what was available at the time. But that was a pretty good start. I think in medicine, an expert system could help medical staff determine next steps by following a structured decision tree. For example, if a patient has persistent chest pain and shortness of breath, then perform an EKG for further assessment. When you perform the EKG, if the EKG detects abnormalities in the heart's electrical activity, then the patient may be having a heart attack. While these rule based systems are useful, they have some major limitations. They can't adapt, they can't change their own rules, and they can't improve over time because they aren't actually learning. They may miss other possibilities.
And that brings us to machine learning, which is fundamentally different from those rule based systems. Instead of following a rigid set of predefined rules, machine learning algorithms learn from data. This allows them to improve their performance over time as they process more information. One of the earliest examples of machine learning was a checkers playing program developed by Arthur Samuel in the 1950s. Unlike Deep Blue, which was given data on an enormous set of already played chess games and preset strategies, Samuel's checkers playing program actually learned by playing games and adjusting its decision making based on which moves led to winning outcomes. This was a breakthrough that showed that computers could actually refine their behavior through experience rather than relying solely on human designed rules.
So, if we take the medical example of the expert system and add a huge spreadsheet full of past patient information like age, weight, pre existing conditions, symptoms, duration, eventual diagnosis, and more, machine learning algorithms could find patterns in that data to help diagnose new cases. Thinking about the example with the patient that may be having a heart attack, in reality, there are many other possibilities other than a heart attack that the expert system misses that an ML approach may actually catch.
Or an easier to digest example about food. Imagine you have an ice cream serving robot that has data on all your previous ice cream choices and what the weather was like at that time and who you were with, and could recommend new flavors based on the current conditions. Maybe you pick more adventurous when you're with your friends and fruitier flavors when it's really hot outside. That's machine learning. It's like teaching a robot by showing it patterns instead of giving it step by step instructions. The more it learns, the better it gets at guessing what you like.
And with the earlier expert systems, instead of having all the data of your past choices, it's more rigid. If a customer likes fruity flavors, then recommend strawberry or mango. If a customer wants dairy free, then recommend a sorbet or vegan chocolate. The expert system is basically frozen in time.
Nah, no pun intended. Or maybe it was intended.
The learning process in machine learning comes from increasing the size of the data set. As the system collects more data, it can find new patterns and make better predictions.
What we've been describing is typically referred to as a classic ML, well organized structured data. This AI system is limited by the data and the human involvement to clean the data. Next week, we'll take things a step further when we talk about neural networks and deep learning. These offer a more advanced way for machines to learn by creating their own internal representations of data. Or more simply stated, creating their own understanding of the data rather than just following preset rules. So, will AI systems be rule breakers in our next episode? Tune in to find out.
That's it for today. Be sure to hit subscribe, share this with your friends, and join us next time on 8 Minute AI.
Bye.